SwayamPrabha. Digital India. Educated India. SwayamPrabha. Digital India. Educated India.
In an earlier lecture, we had looked at how the air traffic management system works, but that was the conventional system. Today we are going to look at some modern trends in air traffic management. The three main topics to be covered in this lecture are the advances in CNS, followed by the concept of free flight, and finally UTM and UAM. Starting with some advances in CNS. As you all are aware, CNS is the abbreviation for communication, navigation and surveillance. These are the three pillars of air traffic services. In fact, the entire edifice of air traffic services rests on these three pillars. So, we will look at some advances in the field of CNS. Starting with communications. We have touched very briefly about the system called ACARS, which as you know stands for Aircraft Communications, Addressing and Reporting System. It is nothing but a text based communication system between the ground stations, that is the air traffic control officers or the ATS units on the ground, not necessarily only human, and the pilots or the crew members on board. Remember, we have all talked about communication using VHF or HF frequency bands, that is voice communication. But this one is a non-voice based, purely text based communication. All of us are using mobile phones, and mobile phones are the de facto means of communication between family members, between friends, between official associates and colleagues. But you will appreciate that nowadays it is not always the case that we want to call someone to talk or to communicate. Lot of us are used to texting or sending SMS, short message service. Those of us who use apps like Signal or WhatsApp or other communication devices like Telegram, we send messages to our near and dear ones, our friends, our associates, using the text facility, and with that there is no need for us to call anybody. Similarly, ACARS is a text based communication system which is from the ground stations and the pilots. Because texting is better than calling, it is more efficient, the message gets communicated, there is hardly any confusion, because when you hear something you may hear something else and you may get confused, but when it is text, there is a text which you can read and therefore there is less confusion. Okay. The communication that happens in ACARS is through various schemes such as VDL or high frequency DL or SATCOM. So, VDL stands for very high frequency data link, HFDL stands for high frequency data link, and SATCOM stands for satellite communication. Okay. Today the satellite communication takes place either using the Inmarsat or the Iridium satellite constellation. There are these two independent constellation of satellites which have been set up by private agencies for communication purposes. So, when you are over sea or when you are in areas where there is hardly any ground based communication system available, we use Inmarsat or Iridium. Many of you who are aware about the communication happening between ships or between ship and ground based systems would be familiar with Inmarsat and Iridium satellite communication. So, let us look at the types of messages which are sent via ACARS. There could be messages which are of relevance and importance to the air traffic control. Primarily, these could be the official clearances which have to be communicated and received. Okay. They could be oceanic clearances or they could be pre-departure clearances or any other clearance. So, when you have an ACARS based air traffic control communication, then the data is recorded and you come to know, you can have a documentary proof later on that there was a communication and clearances were given. Or you could have aeronautical operational control related messages, for example, load sheets, updates about the weather, the flight plan, the information that you received at the flight dispatch before takeoff can also be updated. You could communicate as a pilot the information regarding delays, and there could be automatic reporting of the OOOI flight phases. What is meant by this OOOI flight phases? Let us have a look. So, OOOI stands for out, off, on and in. Out means the off blocks time when the aircraft leaves the gate. This is normally sensed or measured when the passenger or the cabin door is closed and or the parking brake is released. That is when the aircraft is now out of the gate. So, this time needs to be recorded and it can be recorded automatically using an ACARS message. Then there is an off time or the time of takeoff, the time when the takeoff occurs. This is normally recorded by a sensor that is called as the weight of wheel sensors. The sensor gets triggered when the weight on the wheels is released, when the aircraft lifts the ground and when the main wheel lifts the ground and the aircraft is said to have started its takeoff. So, that time is also recorded through an automatic ACARS message. Then there is an on time, the landing time when the weight on the wheels is sensed when the aircraft touches down. And also there can be an in time, the last one, which is the time of arrival at the gate. This is measured when the parking brake is set or when the engines are shut down. That is when a message gets triggered automatically to to the central server that the in time has been achieved. All these times are important because they are a way of keeping track of the aircraft, because there is a mandatory reporting required to the regulatory agencies. Therefore, it is important to have these times recorded, and with ACARS they can get recorded automatically. The pilot does not have to proactively do anything. So, that much less workload for the pilot. You could also have messages regarding the engine health which are being communicated directly by the aircraft through ACARS to an engine performance monitoring station, and you can also get information regarding the gate at the airport. So, when you land, the pilot already comes to know at which gate you will go. Sometimes you also come to know about where the aircraft is headed. So, all this information can be communicated in a textual fashion using ACARS, and then there could be airline administrative control, like how many passengers are there, which are the seats which are occupied, which seats are available, information regarding the passengers. If there is any medical emergency regarding a passenger, that information could be communicated. If the flight is going late, then information regarding which are the gates for all the connecting flights, so that the passengers do not waste time After landing, they can quickly rush to the desired gate. This information can be communicated using ACARS by the airline control center to the aircraft. Otherwise, you normally come to know about these information after you land and look at the display, but you could get the information directly using ACARS inside the aircraft. Here is an example of how the presence of the ACARS system on the aircraft helped. We are all aware about this very tragic case of the Malaysian Airlines flight 370, which vanished without a trace, and it is a huge mystery, unsolved mystery as yet, about what exactly happened to flight 370, why did it just deviate from the path, where did it go, how did how did it land in the ocean. Some few components of the aircraft have been located, the FDR is still not located, so therefore the mystery is still unsolved. Now there is a unit in any aircraft called as the satellite data unit, or SDU, which uses the ACARS protocol to communicate information regarding the aircraft with the satellite. So in this case, the SDU got turned on automatically around 1 hour after the plane vanished from the secondary surveillance radar. So an SDU ping was recorded on the satellite, and that ping actually helped us to get an idea as to where the aircraft was. So SDU and the Innermar satellites, they were in contact, but there was no response from the pilots. So that means by that time already the tragedy had happened. However, with the signal automatically getting transmitted, we got an idea about where it was, and then the experts actually tried to trace the arc where the aircraft could be, because they knew that at this particular time the aircraft sent a ping, so it was somewhere here, and after some time where it would be. So they could actually locate the likely area where we can search for this debris of this aircraft. Okay. So this automatic ping message, which was answered automatically by the SDU. Okay. 70 minutes after the SDU got turned on, a message was sent automatically, and that way you could calculate the approximate location, but that is not the purpose of this signal. This is just a secondary information that we got. So yes, ACARS has been helpful also in this particular case. And with this, the theory of power failure and rebooting of the aircraft was propagated. As I said, it is still an unsolved mystery. Okay. Now there have been some improvements in ACARS, further improvements, because flights are generating more and more ACARS data, and every flight generates ACARS data. There are so many flights in the sky at the same time. So when they are communicating, then all the bands, they get overloaded. Okay. Whether it is VHF, HF, narrowband or SATCOM, they all get overloaded because too many aircraft are transmitting too much data. So therefore the solution is to use ACARS over a dedicated network, that is over IP. Now we are not new to internet protocol, because we use VoIP, voice over IP, we use it to communicate. All the phone calls that you make using these using the apps such as WhatsApp, such as Telegram, such as Signal, they are all VoIP calls. Okay. So we are not new to it. So ACARS also uses internet protocol, but there is a problem. The problem is that if you use publicly available broadband, then you can only use it to broadcast non-safety critical messages. Safety critical messages cannot be sent on public domain. So therefore for that we still use VHF and SATCOM. Okay. For the dispatch critical and for ATS messages, we only use reliably, and again we further protect the communication using what is called as VPN. So an aircraft interface device, or AID, is required. All the new aircraft have this device, and old aircraft, they can be retrofitted to have this particular device. This particular device uses VPN for protecting the information, so that it is not publicly available, because it can be misused, it can be used for some nefarious purposes, even to harm the aircraft. Surveillance using ADS-B. ADS-B we have already discussed in the previous lecture. you know that ADS-B stands for Automatic Dependent Surveillance Broadcast. Why automatic? Because the information is broadcast automatically without any input or attempt from the pilot or external sources. Dependent because the accuracy of the information is dependent on the sensors which are there in the aircraft. Surveillance because information about the accurate position is broadcast, and broadcast because the information is continuously sent and it can be received by any station. So, this is something that anyone can actually tune into. So, you can use the ADS-B information to track any flight. That is the interesting part. This particular information is used by many flight tracking programs. One of them is something called as flight radar. Let us have a look at flight radar. This will give you real time traffic data, what is happening today. So, for example, right now we are at Mumbai, and if we zoom into Mumbai, you will see there are all these aircraft. So, this is the Mumbai airport. You can see there is one aircraft which is taking off. This aircraft is IAD 679, and if I click on this, I will get the information. IAD 679 actually is an aircraft which is, oh, this is landing, because this is from Goa to Mumbai. So, it has landed, not takeoff. Scheduled departure was 125, actual was 210, it was delayed. Okay. Scheduled arrival was 240, but it is coming at 1 minute past 3 o'clock, which is the current time. So, once it has landed, it is now exiting the taxiway, and the other one is ready for takeoff, which is VTI 944. This is the call sign. This is the aircraft from Mumbai to Delhi by Vistara Airlines, okay, scheduled to leave at 2:40. It is a bit late today. So, as you can see, real time information regarding the traffic can be tracked on devices like flight radar. So, here we see the aircraft taking off. This is the same VTI 944, and the other one IGO 7292 has landed. This is an aircraft which is going from Mumbai to Hubli. So, it is now going for departure. The departure time was 2:50, and it will be landing at Hubli at 4:25. Behind that you have one more aircraft IAD 679, which is again, it has landed. Okay, it has landed and it is now coming taxiing. Okay, so let us see this aircraft. It has now left. So, it is flying. Here we are getting a 2-dimensional view, but you can also have a 3D view. There are other aircraft. Look at this very interesting fact that ADS-B also is mounted on various ground based equipment such as these. So, you can see this is the follow me car. Some information is not available. Okay. So, here is IGO 6704, which is an aircraft that flew from Kochi to Mumbai. It came, it landed and it taxied, and it is now out going towards the terminal. Okay. So, it is a flight from Kochi to Mumbai. So, you can see that real time motion of the ground based equipment as well as the aircraft can be tracked. So, this aircraft is now ready for takeoff. It has taxied and it is now going to align with the runway. It is waiting because this aircraft LLR has just arrived. This is from Keshod to Mumbai. It has just come in to land. So, once it lands and exits the runway, you will see this aircraft will get clearance to move inside. So, as you can see, it is already started to move towards the runway, and behind this is this aircraft lining up IAD 679, which is Goa to Mumbai, the one which has just arrived. There you can see our aircraft has now entered the runway, because this aircraft is almost about to vacate the runway. It is holding near the end, and now it is ready for its takeoff. It will have to wait till this aircraft clears the runway. Once this aircraft exits the runway, this will happen very soon. There you go, the aircraft has now left the runway and gone to the taxiway. This is the rapid exit taxiway. Now, our aircraft IGO 7292 will proceed for its takeoff once it gets the clearance and the approval from the ATCO. There you go, approval has been received, and so the aircraft is accelerating on the runway. I will zoom a bit further. So, you can see So, gone. So, this is how using signals from this software one can keep a track on what is happening in real time, and this information is free of cost. Let us look at surveillance using ADS-C. ADS-C is automatic dependent surveillance, but now it is a contract, it is not broadcast. So, information is available on contract by ground station, it is not broadcast to everyone. So, only if you are authorized you will receive this information. Okay. So, the ADS-B position updates frequently, but ADS-C is only once in about 10 minutes time. Therefore, because of very quick updates, ADS-B position updates give you better surveillance, but ADS-C is used for remote areas or for the oceanic navigation. Okay. So, ADS-B range is limited, you need to have your receiver near the destination, near the aircraft, okay, because it uses only transponder. The signals from the transponder are used in ADS-B, but if you use ADS-C, then you use satellite communication, and therefore, the range is much larger. Okay. Going one step further, we can use space based ADS-B. This is the latest development by a company called as Aeron LLC. What it does is, there is a Iridium satellite network which covers the entire planet, and this particular network is used, the satellites in this network are used to communicate the information in space based ADS-B. This particular system became very popular after the infamous 370 MH370 crash. It boosted, and there is now a push for giving large oceanic coverage using the space based ADS-B. It covers large areas in the oceanic airspace, and therefore, it allows you to have a lower separation. For example, in the North Atlantic tracks, which are the tracks between USA and Europe, very busy tracks, and there are multiple parallel tracks. This ADS-B using space based navigation was implemented in 2019 and 20. So, we can see that because of this, the information is accurately available about the location of the aircraft in real time. Therefore, the longitudinal separation could be reduced from 74 kilometers to 26 kilometers. Imagine how much will be the increase in the throughput because of this particular feature. Similarly, the lateral separation was reduced from 43 kilometers required earlier to 35 kilometers. This also will push a lot amount of traffic. Okay. Now, because of the accuracy that ADS-B space based systems provide, more and more countries are opting for space based ADS-B. So, very soon this will become the default system on all aircraft of all airlines in the future. So, this is a picture given by the company Aeron. It says that the current system is only focused on the line of sight based communication. So, over hilly areas, over oceanic airspace which is far away from the center, like in this scope you can see, you do not have much coverage. But if you have global space based ADS-B coverage, then you can use satellites which are there in the space for communication. There are some ground facilities which have been created by this company. Using those ground facilities and using other facilities, you can provide communications coverage to a larger number of aircraft flying in the air. There are many other advances in CNS, let us look at them. Most of the systems that are available in the aircraft are slowly being updated from the old ones, right. So, we know that there is something called as TCAS, Terrain Collision and Avoidance System. This is being updated to ACAS-X, Advanced Collision Avoidance System -X. This allows you to have reduced separation and more uses are also there. Similarly, the navigation models they will follow the ADS-B data to improve the accuracy with respect to the presence of the other aircraft, because now you will get the ADS-B information directly. In the US, we have next gen air traffic management system, which stands for next generation systems. In Europe, we have the Single European Sky ATM research, that is SESAR. These are the new and updated ATM systems which are being implemented in US and Europe, and they are slowly going to implement the free flight plans, about which we will hear little bit later. Okay. And data driven research is the key for free flight and for next gen, and we will see how is it possible. So, why data driven research, and let us show you an example. If you look at the physics based approach which is followed, it is a simple representation of a real complex system, and it is based on the data from measuring the system behavior. It is based on actual data observed from measuring of system behavior. However, data driven models, they can take into account uncertainties. Okay. For example, there could be change in the weather conditions, and this is very common, and then it can also incorporate the dynamics of current flow. Here is an example. In this figure, WMKK stands for the Kuala Lumpur International Airport, and WSSS stands for the Singapore Changi Airport. So, the red line that you see in this particular figure is the actual theoretical airway or trajectory, actual theoretical trajectory or physics based trajectory between these two airports, but all the other lines that you see, those are the actual trajectories. So, notice that although in the predicted trajectory you are supposed to come down from WMKK and then go along this line, again come down and then turn and land, there are many instances where their airline actually flies on the other direction and then comes down. Okay. So, these kind of deviations normally occur when there are weather disturbances or there is huge traffic in the air. Okay. So, you can see how closely the theoretical diagram or the theoretical figure, how closely are the operations matching with it, but you can see that there are also large amount of deviations. So, when you use data driven models, you will get more information based on realism compared to the physics based simulation. What are the research avenues in ATM? Data driven approach is now becoming a need rather than just being an assistance to the modeling. Okay. There are novel techniques which are coming in to help in ground en route terminal area ATC operations. The data driven research is also being used for flight delay and trajectory prediction, because you have vast amount of data available about what actually happened, and with that you can actually predict and propose what is likely going to happen. This way one can incorporate real time air traffic control data into the design of the aircraft. So, we are very far away from this situation right now, but still we are slowly moving in that direction. Then there is also a requirement for a detailed study on the effect of automation on ATCOs and the cyber security that is impacted because of this. So, a large body of work is being done on the effect of automation on ATCOs. The problem with the data driven model is that there is going to be a data set shift and there is going to be poor modeling of physics. This is inherent in the nature of physics. Let us look at an example where data set can be shifted. For instance, there may be a flight that is scheduled to depart at a particular time, but because of delays it departs at some other time. So, that information is available, but it is relevant only to that particular scenario. It cannot be used for all scenarios. Let us move on to the next important topic, which is the free flight. What is free flight? Normally, which is abbreviated as FF. In free flight, we would like to remove the air traffic controller from the picture, and we would shift the decision making from the air traffic controller to the pilot in the cockpit. Okay. and this is a very bold step, but that is the way in which we are going to proceed in the future. The two important tasks which are conducted by the air traffic manager are the management of separation and the conflict detection and resolution. These two components are going to be done automatically by the aircraft and the system in the free flight scenario eventually. Why do we need free flight and what is the benefit of free flight? Is it to reduce the expenditure that we incur in air traffic management because of the presence of ATCOs? No, that is not the thing. It is not necessarily to just save on the salary of the ATCOs or to take away their jobs. No, there is much more deeper reason for that. Okay. ATCOs generally ensure some minimum separation between the aircraft. Okay. Why do they do that? They do that because there are places like Asia and Africa which have huge areas with no radar coverage. So, therefore, the exact location of the aircraft is not known to the ATCO. There are no support instrumentations available. So, therefore, they have to predict the location of the aircraft as a function of geometry by projecting the position from the current position, and there could be errors in that, and therefore, the safety is ensured by maintaining separation between aircraft. Lesser the confidence level on the information that is available about the aircraft, and also lesser the information actually available between 2 points, more will be the minimum separation which will be maintained by the ATCOs for safety. Then if you have a very high density traffic situation, you will find that the ATCOs will get into a workload issue. It will be difficult for them to manage the workload if it becomes very congested. So, then they will buy some time by increasing separation or by making some aircraft to go on hold, so that in the meantime they can look after the other critical aircraft. Also, the oceanic navigation, it follows a railway type model between the waypoints. So, it is like you have two waypoints, and if you are not sure about the location of the aircraft as they fly along these waypoints, you will allow the next aircraft to enter. So, if there are two waypoints and there are aircraft coming from both sides, so what you will do is, when this aircraft leaves the first waypoint and goes to the second waypoint, only then you release one more aircraft. Okay. So, these kind of a model which are followed by the railways, that you release a train when one train has already reached the destination, then you release the train. This system is inefficient, but there is no other way to ensure safety. Okay. So, what are the main considerations of free flight? The main consideration is significantly reduce the separation minima which have to be followed to ensure safety, and also this can be achieved by improved conflict prediction, detection and resolution. Secondly, we would like to avoid the ATCOs to do micromanagement at various places like at the gates, at the runways, at the airways. We want them to focus on one particular task, and we don't want them to be burdened by doing multiple small tasks. So, many of these tasks are going to be taken over by free flight. Why free flight? Here is an example. If you are in IIT Bombay and you are at a place called IDC, which is the Industrial Design Center, and you want to go to Hostel 5, or vice versa, from Hostel 5 you want to come to IDC. When you ask Google Map, it gives you two routes. This is a walking route. So, one route is you go like this, the dotted lines, and then you come to IDC. This takes 23 minutes because it is 1.6 kilometers walking distance. Or at this point you could take a turn, go on the road and then come to IDC. This particular distance is longer and therefore it takes more time. Unfortunately, you cannot go from IDC straight like this because there is no road here. You have this road, but then it ends here. You have no way to go directly. Okay. Similarly, the airways which are available in the air, they are between 2 points, but they are not the optimal points. They are the most convenient points, keeping in mind the availability of the navigational aids and other facilities, but they are important for traffic management. So, free flight ensures point to point navigation with self separation, this leads to increase in capacity and reduction in congestion. It is like you can get a direct path from hostel 5 to the location you want and back. What are the other advantages of free flight? In ATC services, where real time information is very important and one needs to keep a track, there will be a huge problem if there is a complete power failure. It does not normally happen, but it can happen anytime, and till you have a backup power available, this is a huge risk. Okay. So, for this the ATC prints what is called as a flight progress strips for an aircraft every few minutes. Okay. Now, this particular strips, they contain information regarding the aircraft, its ID, at what flight level it is flying, what is the destination airport, what is the departure airport from where it came, what is the navigational time. Okay. These copies are updated for every aircraft frequently, and today also we use the physical copies for power failure risk. Okay. Right. So, free flight removes the risk, but there is also a risk of telecom failure which you can't help. So, here is an example of how flight strips are stacked one above the other to keep a track on the aircraft as it is flying in the sky. Moving ahead, let us look at some headlines. Okay. Here is a headline from July this year: thousands of summer holidays at risk after European air traffic control staff announced strike. Okay. There could be issues, the people is having a lot of anxiety, right. Now, in US there was another strike. Interestingly, the USA currently employs 1,200 lesser controllers than it did 10 years ago. So, there is a feeling in the minds of the management that because of technology you do not need so many people, okay. But that is not exactly true. So, you can say that there are articles about safety crisis with the air traffic. Okay. This is in Sydney. So, the problem is also there in Australia. Reuters, September 24, 2022. Lebanon, India. You look at articles of 2016, it says India has lack of ATCOs. In 2018, India grappled with the acute dearth of air traffic control officers. In 23, I am a former ATCO and I am not alarmed by the current situation. So, there is no doubt a crisis in the ATC. Okay. It is not perfectly fine. All is not hunky dory in air traffic management services, and that is one big driver for the free flight. The number of ATCOs is almost insufficient. You cannot overload them because they do a very sensitive work. So, therefore, you have to go for staggered shifts, and this is very delicate from the safety point of view. And the ATCOs being overworked, frustrated, they can resort to repeated strikes, and when they do repeated strikes, the traffic comes to a standstill. This is very well known to the governments and to the civil aviation authorities, okay. But they do not prioritize it, they are not filling the blank spaces because the ATM reputation is not enchanting for people. There was a time when this was considered to be a very, very excellent and fascinating job, but today people know it is highly stressful. In India, the ATCOs work for about 10 hours a day duty, and every 2 hours there is a compulsory break. They have to take a break, relax, and then come back again. It is so stressful. So, the reason is that air traffic is bound to increase year on year, and that correspondingly leads to the ATC workload increase, no doubt about it. Okay. So, in the last decade, around 12% domestic and 6.6% international traffic compound increase compared to the last decade, and this data has come from the DGCA in India. The key purpose of air traffic management services or ATS is to ensure and enhance safety of aircraft, and studies have shown that the ATCOs are responsible for around 6 to 10% of all the accidents that take place. The idea of free flight is to reduce these numbers, but is it possible? Let us look at history to find out whether it is really possible and what happened. So, there are two examples I have. The first example is of the world's largest mid-air collision at a place called Charkhi Dadri near Delhi. This happened way back in 1996, but the wounds are still very fresh. So, this accident took place between aircrafts of an airline from Kazakhstan and Saudi Arabia. The pilots from Kazakhstan had communication issues. They descended from flight level 150, which is 15,000 feet, to flight level 140. Okay, they descended slowly, they went about their task slowly, and they knew that there is an incoming aircraft at that altitude, but they did not really bother at that time. So, when they slowly came down to flight level 140, they realized their mistake and they decided to climb. Unfortunately, during the climb, they collided with an aircraft from Saudi Arabia, Arabian Airlines, which is F763. This particular incident has been captured very beautifully in a 60-minute TV documentary on this incident called as the Head-on Air Crash. This documentary was available in the year 2006 on Netflix, but right now you can search where it is available, try to get a copy and try to watch. It is a very fascinating movie that completely describes the situation that took place at the Charkhi Dadri for this air-to-air collision. What is the solution to this problem? Well, as soon as the accident took place, the DGCA of India under the leadership of Mr. H.S. Khola decided and mandated that all aircraft which enter the Indian airspace should necessarily have TCAS system enabled. We were among the first nations in the world to make TCAS compulsory. Okay, so we took a very bold decision, and also because the accident took place between arriving and departing aircraft at the same airport, the air routes or the airways near the Indira Gandhi International Airport, they were modified, so that the departure and arrival are not on the same route. Okay, there is a separate route for departure and separate for arrival. This I have shown you in the lecture on navigation. Okay. And then a secondary surveillance radar was installed at New Delhi airport to ensure that positive identification of the aircraft is available to the ATCO on the screen. The next example is from Germany. In the year 2002 at a place called Oberlingen, there was a mid-air collision. The TCAS instrument on board told one aircraft to climb and the other aircraft to descend. Unfortunately, the air traffic controller gave the opposite orders. Now, one aircraft follows the TCAS instructions, the other followed the ATC instructions, and both of them came to the same altitude and there was a crash. The solution that given to this particular problem was that in this kind of a scenario where there is some alert given by the TCAS, this is the only place where the commands given by the ATCO can be neglected, can be overlooked by a pilot. TCAS is more important because TCAS is near the area where the incident is taking place. So, the information of TCAS is more accurate, and TCAS collaborates with the other aircraft and gives a combined instruction. One aircraft gets instruction to climb, the other to land. So, therefore, there will be no chance of a collision. And there is a very weird trivia, very horrific trivia. The blame of this accident was passed on to ATCO because it was felt that the ATCO is the person responsible for this crash, and the concerned air traffic control officer was murdered by a man who lost his family in the crash because he held him responsible for this particular incident. This particular accident is very beautifully captured and documented in a film which came in 2017 called as The Aftermath. So, please locate this film and try to watch. It is available on YouTube. So, what is the outcome of these two ATC crashes? larger reliance on technology, because free flight seems viable to reduce the ATC induced crashes. Okay. But the ATC induced crashes are only between 6 to 10%. Okay. What about the pilot? Pilot error is known to be the major cause for more than 60% of the accidents or crashes. So, the free flight is expected to increase the workload of the pilots. That is what you think in the first impression. Okay. But how crucial is the pilot burnout? How crucial is it that the pilots make mistakes? Let us again look at history to find out. There is a very famous incident of what is called as a ghost plane. This is what happened to Helios Airways flight 522. In this particular aircraft, during the pre-departure checks, by mistake, the pilots left the cabin pressurization system on the manual mode, whereas it should have been in automated mode. Now, the oxygen masks that are available on board the aircraft, they are required in a situation when you have a lack of oxygen, but the amount of oxygen that they carry is only for about 10 to 12 minutes of flight, not more. Okay. In this case, the cabin crew failed to comply with the depressurization rules, and a movie called as Flight 7500, shot in 2014 or released in 2014, was loosely based on this particular incident. Let us have a look at two accidents that occurred because of pilot error. The first of them was the Eastern Airlines Flight 401 in 1972. There was a faulty landing gear in the aircraft, and the pilots were completely fixated in trying to crack that problem, trying to somehow make the landing gear work, and in the process they failed to recognize the loss of the altitude that the aircraft was undergoing. And the reason for that is that by mistake they had altered the autopilot settings, because of which autopilot was not working. So, there was no warning given regarding the altitude loss, and also no corrective actions were taken by the autopilot automatically to cancel the problem because of this issue. So, there is a movie called as The Crash of Flight 401, which appeared in 1978. That movie is based on this incident. Another one is Trans-Asia Flight 505. It suffered a single engine failure, it suffered a one engine failure. So, what are the pilots supposed to do in this case? If you have a multiple engine aircraft and one engine fails, you just turn off that engine and work on the other engines. In this case, unfortunately, the crew members switched off the good engine instead of the non-working or the bad one. So, they complicated the problem. Two engines are there, they out of that one of them lost the power, you put the other one also off. Okay. Again, this is also a very interesting episode in the Mayday TV series of Europe. In 2017 it was launched. Episode 7, session 17 is about this particular flight. Pilot burnout is a very key issue. It is very difficult for a person, for a human being to stay alert for most of the phases of the flight. Tiredness can set in unless you have taken proper rest. In this direction, the airline policies sometimes are not very supportive. Many airlines make the aircraft pilot to do lot more work than what they are supposed to do because of economic considerations. In some cases, the pilots themselves do not take enough rest, or they do not limit their alcohol, which is permitted as per rules. So, they also have a problem of self ethics in some cases. So, one of the aims of the free flight technology is also to reduce the pilot workload as well. So, the backbone of free flight is human factors plus technical aspects together. Let us see what is the focus of the technology of free flight. The first priority of any free flight is to maintain self separation so that there is no collision. After that, you have to look at conflict detection and resolution to avoid a possible conflict in the future, but only after the first priority is met. Another task which is required is to develop the optimal paths without any airways, so that point to point connections can be given. Field flight should also provide support to the pilot with data and information during the takeoff and landing phases, and they should reduce the pilot workload and prevent the pilot burnout. Okay. So, one interesting system that is implemented nowadays is called as the Airborne Separation Assurance System, or ASAS. This particular system predicts the possible conflicts which can mushroom in the look ahead time frame in the near future. Okay. And it uses the data from ADS-B, not only your data, the data of other neighboring aircraft, and then gives the pilot an overall good picture, and also tells the pilot of the imminent conflict. Okay. But this system had to be quick and simple. It should be complex, it will be difficult for the pilots to understand. So, an average pilot should be able to use information from ASAS to get a good idea about the emerging conflicts and to get an idea about the possible resolutions also. I will share with you some work on collision prediction by trajectory prediction. So, when you want to avoid collision, you have to definitely have an idea about the trajectory of all the players in the field and your own trajectory. Okay. So, to do this, there are 4 possible approaches. To do this, there are possible 4 approaches. Once again, to do this, there are 4 possible approaches. The first one is called as the no intent approach. So, here only the position of the current aircraft is available, and you extrapolate the future position using the velocity of the aircraft, but you do not have any idea about the intention of the pilots. The second possibility of this particular technique is you infer the trajectory from the autopilot information, because that will give you the situation in which the aircraft is imminently there. The other aspect is identify the next target change point. So, whenever we fly along a particular path, we will be forced to change our path at some locations, at some predetermined locations, maybe because there is a navigational aid below it, maybe because that is how it has been planned. So, if you get information regarding what is the next destination of this aircraft, what is the aircraft origin, what is my origin, my destination, are these paths crossing or are they separate, this can help you in identifying the possibility or not of a conflict. And finally, one can use IT to know about the complete flight plan as per the FMS rules. This is something that people do not like, because this kind of breaches their ability or breaches their privacy, but it is the best way to keep a track on the trajectory and to predict the harmful or collision prone trajectories. Okay. And the fourth point could be that you know the complete flight plan of the aircraft, your aircraft and the other aircraft as per the flight management system. This is the ultimate, because complete information about the intentions, about the plans of all aircraft are available to you. So, you can easily figure out where there is a possible conflict, although the number crunching required will be quite large, because there are many aircraft in the vicinity and you have very limited time to give them information, but still one can try it out. Interestingly, the no intent approach, which was the most basic one, turns out to be the least complex and the most pilot friendly. Okay. So, what you can do is you can draw a look ahead zone, which is nothing but a circle with the center of the aircraft, and r is the distance to cover in t minutes. So, you get a map, let us say this is the map of India this is the map of this particular airfield, and there is one here, one this direction, one this direction, one that direction. That is all decided based on the look ahead zone. So, conflict detection is done with aircraft in the look ahead zone, and problem is, what if they take an unprecedented turn? Right now you only know their intention, but they may not always behave as per their intention. There could be many reasons for that, let us not get into that, but there could be an unprecedented turn, for example. Then what will happen? Okay. So, just do a thought experiment. Imagine you are in the movie theatre, you have purchased tickets. So, your seat numbers are D, 4 and 5, and somebody else also has purchased the tickets and their seat numbers are P, 9 and 10. Now, there is a common gate through which all the people arrive. Generally, there is only one gate at the cinema hall. Now, when you enter, you know where you have to go, and the path of the various people could be conflicting, could be overlapping. Okay. So, what you do is, if you want to avoid any conflict, you would probably move along the flow. At some point, you might wait and allow the other person to take a lead and go and settle in the destination, so that you can have a less complex and error free path. But suppose the person is walking down, you have to give way, so you have to change your trajectory. Suppose there is somebody already sitting in your place when you reach or about to reach, and they say, please, could you please move to that seat, because I am with my family and I would like you to go there. So, all these things are possible, correct. So, we can ask the pilot to check the intent of every aircraft before they turn, but this becomes very cumbersome and the pilot workload will greatly increase. So, there is something called as predictive ASAS or PASAS. What is predictive ASAS? It calculates the speed vector and changes to the horizontal and vertical for the conflict detection resolution. Okay. So, maneuvers with possible conflict in the look ahead time are forbidden. So, each aircraft pair you come to know which area entry will be permitted, and if the path goes outside that area, you might be not given permission. Okay. So, in the passive ASAS or PASAS, if a maneuver that you want to perform leads to some conflict detection in the look around time, they are forbidden. So, what will happen is, no aircraft will do a risky maneuver and therefore, everything will be safe. The throughput may be affected, the efficiency of operation may go down, but safety is ensured. Okay. So, the conflict resolution of free flight has to be much more advanced than in the TCAS, okay, because in TCAS you normally change the altitude, or rarely you change the heading also, but it is mostly altitude change. In ASAS, you actually find the most optimal way to do the conflict resolution, and there are many theories in development. We do not have the time to really talk about these theories in detail. There is a very interesting feature called as the cockpit display of traffic information. This is like an information to the pilot about the traffic that he or she is encountering while flying. This system has to be easy to use, it should also be user friendly, and it should be easily commandable, and it is possible to override by human beings, because if you blindly believe what you see, then you have a tendency of blindly following that, and that can lead to dangerous situations. So, human in the loop simulations are being conducted today on a cockpit display of traffic information system, and hopefully this will become a part of the next generation or the SESAR initiative. And finally, we come to the last part of today's lecture, which is on UAM and UTM. We will see very soon what these terms stands for. Let us first focus on the UTM, drone delivery. Okay. So, all of you are aware about drones. Generally, the word drone is used very freely to define multicopters or quadcopters which are able to lift things and deliver somewhere nearby. So, there is something called as a last mile delivery, which is, for example, when you place an order on an item, the items are shipped to a warehouse near the city, and from the warehouse delivering this to the individual consumer is called as a last mile delivery. So, using drones for last mile delivery is gaining acceptance. The origin is that historically the aircraft which were having new technology like this were infeasible aircraft. They would be very heavy or they would not have the features required. Okay. So, historically drones were used mainly by the military. Currently drones are used all over the place for monitoring, for data collection, for photography, for racing, leisure, and the new activity is medical deliveries. In fact, in future it is expected that medical deliveries are going to be the backbone of the developments in LTA systems. In the future there will be more medical deliveries, last mile products will be sent via drones, and also the food deliveries like Swiggy and Zomato in India, which are happening today by bikes and by cycles, they will happen by drones in the near future. So, market studies are forecasting a demand of more than 100% and increase for the last mile deliveries. So, the last mile delivery will become 100% more, and it was also found by many major service providers that 84% of the products which are sent today by trucks or by other vehicles, they are actually drone deliverables. They can be put on drones and they can be delivered at precise locations. So, let us see, the current air traffic management infrastructure is totally insufficient to meet this new demand, because we are already saturated with our facilities. On top of that, if you bring in some more regulations, it is going to be a disaster. And also remember that till date drone operations are only permitted in class G airspace, the free airspace, as you can see. So, this is where the UTM operations are allowed on the bottom 400 feet above ground level. Above that the whole thing is controlled. Let us look at the present and future of the UTM. So, if we use drones in an uncontrolled fashion in the urban spaces, there is going to be a huge safety risk. So, it is not permitted. Currently we allow only remotely piloted aircraft UAVs, we do not allow autonomous UAVs today. In the future you will have automated drones, but you will require control on them. Okay. So, the UAS traffic management, which is abbreviated to UTM, this will require a new framework to be developed, and that is the area in which many people are working. So, what are the key features of UTM? First of all, we need to develop the airspace structure to accommodate the drones. We have to plan a rollout of the drone delivery system, but it has to be in a phased manner. You try something and then more and then more and then more. Then we should decide on the regulations for the current scenario. These regulations could be tight today, but they will be relaxed later as experience builds up and as the expertise also builds up. And you have to develop a traffic flow and control framework for the urban air vehicles. Plus, you need to ensure that the safety of everybody is maintained, and for all these things you will need a central management system or CMS, which has to be developed. So, the civil aviation authorities and government bodies taking care of UTM, that is their main job. In US, in Europe, in Japan, China, Singapore, Korea, Australia, they were the first people in the world to make a framework for drone operations. Okay. India is going to follow the European standards, and we have already signed a letter of intent based on that particular meeting. So, it is going to happen very soon in the country. So, in the areas around the airports and in the areas which are restricted airspace, integration of UTM with ATM will be needed, because you cannot operate without the help of the other. Okay. So, one model in US, it opts for corridors with TCAS equipped drones and heavy aircraft. So, if there are heavy aircraft, which have TCAS equipment installed on the drones, then one of the US models is developing the corridors for this particular requirement. What are the challenges? The challenges is that there is a direct data link with the CMS. Okay. So, CNS ATM again. So, in C you will have a communication direct link with CMS. In N you will use GPS and 5G networks or maybe better networks, and S will involve two kinds of sensors. One will be a collaborative sensor, one will be a non-collaborative or solo operational sensor. And once you start using CNS on drones, you will very soon come up with congestion of the bandwidth. So, here is an example. If you look at the first two, ADS-B and TCAS or ACAS-XU, you see that they are collaborative type because they take care of both sides. Okay. But the detection range of ADS-B is much higher than anything else, it is around 240 kilometers, right. And then if you go down, you will come to a lot of collaborative work. So, ADS-B and TCAS, ACAS-AU are collaborative in nature. Okay. Therefore, they are the top and they also have the highest detection range. Okay. All the others like optoelectronics or synthetic aperture radar or LiDAR or acoustic system or visionary system, vision based system, they are all non-collaborative, they are all working independently on each drone separately, and the range also reduces very drastically from 214 kilometers to only 1.9 kilometers. But the most accurate system out of these is the bottommost, the vision based system. Although the range is only 1.9 kilometers, still it is very powerful and very much capable. So, the safety separation which is incorporated by the ATCOs actually is very conservative, okay, because the real life multi-drone scenarios do not exist. We do not have them yet in such large numbers flying. So, all our experience, all our knowledge, all our standards are going to be based on whatever we are experiencing, and that is very conservative. Okay. The model that we can use to predict the time window or the distance window or both could be utilized for doing the resolution of the conflict. The separation between two aircraft could be static or dynamic. For example, if you look at static separation, it is a fixed amount of distance or bound between any two kinds of drones. It does not take care of the weather, it does not take care of any situation arising out of any previous built up of error in communication, in navigation, in surveillance. It assumes that both of them are working at peak capacity, and between two of these there will be a fixed static separation. That does not work always. Dynamic separation will have different drone pairs, they will have different separation criteria because everything matters. Okay. So, you will give in this system warnings similar to air traffic management. Okay. For example, when you go into the collision volume, you will be responsible yourself. This is something like the VFR operations, and self separation volume is something which is available to the pilots through the support of the intermediate air traffic management services. Okay. So, the actual conflict resolution by drones will be held collaboratively. The question that arises is, how would an autonomous drone know about no fly zones? How do we teach that particular system the go no go areas? So, we can do that by something called as geofencing. Okay. You can do it geofencing. So, you can say that there is a no fly zone and you cannot go outside this zone. So, there are three methods to mitigate the geofencing intrusion as shown here. Okay. One can have a procedure for mitigating the unintended intrusion of a no fly zone. One can have a procedure for leaving the no fly zone where you are activated by mistake, or one can have through proximity alerts. Before you enter itself, you will be warned and you will be thrown off. All this is fine in rural areas, but in urban areas there are further challenges. Urban areas generally have tall buildings, and buildings are the ones which have a lot of weight behind them. So, interaction of the wind with buildings, it causes large eddies. As you can see, all items which are in red color here show you those are places where speed is more than 5 meter per second velocity, and that is the upper limit that actually a drone can take in general. So, you need to create cause highly turbulent, there are highly turbulent wind gusts, and you need to plan out for them. As you can see, only the gusts less than 5 meter per second are normally handleable by the current drones. So, you have to identify areas other than red and yellow in this particular figure, which you can use to come up with the information. And you can also tell us that if we have this facility, then we might be able to make it available for other researchers also. What is the current scenario in India regarding the drones? Each drone and the pilot has to be registered with DGCA. You simply cannot fly an aircraft just because you know. You have to get yourself registered as a drone pilot, and also the drone has to be registered with a unique ID for each drone. Okay. The airspace in India is divided into 3 parts: the green, yellow and red zones. Now, whenever you fly in yellow and red zones, today you have no choice. You have to file a flight plan and upload it within the time minima, and it has to be approved by the air traffic management authorities. So, you just can't operate without any a priori approval. But green zones are the areas where you can have free flight, where there is no need for you. So, let us look at the digital sky map given by the DGCA of India. This particular map will show us the various zones as we see it today. So, here you can see all these areas which are colored in green, you can fly drones without any problem. But the moment you come near to, so you can see here green, orange and red. So, I have just chosen some local areas. So, Babina and Jhansi are very famous defense area. So, they have lots of areas under red color. So, that is a restricted airspace, you can't fly there. Orange area is the area where you can fly with giving a flight plan, but green area is where you can fly freely. Okay. Similarly, at all the places they have created some zones which are the zones that you have to avoid. Okay. Moving close to home, if you look at now Mumbai, there you see in Mumbai huge areas in the sea because of Bombay High are no fly zone, and the city of Mumbai is completely banned. You can see nothing is allowed in the city of Mumbai unless you operate within the green area, right. So, you can see that you have the airspace in green, yellow and red colors, and you have to accordingly decide where you are going to fly. So, this is what we have at present in the country. What is planned in the near future in India as far as drones are concerned? There will be hundreds of fully autonomous drones flying all around the country. Therefore, each of them is going to have a unique RFID for CNS like in the aircraft in ATM, and if you have no human involvement in flight except the centrally management system, then that is the epitome of free flight concept. And the role of CMS will be to maintain the airways, to ensure geofences are applicable, information regarding unidentified flying object and the rogue planes, weather, etc. All this information will be communicated by CMS. Everything else will happen autonomously on its own. This happens in the future scope. Finally, we look at the last aspect, which is the urban air mobility. Urban air mobility, abbreviated as UAM, basically you know that congestion in urban areas is the huge problem. All of us who live in urban areas know that the traffic on the road is increasing and increasing and increasing, and we do not see anything in sight. Cities like Bengaluru, Hyderabad, Delhi, Mumbai, we experience traffic snarls and traffic delays almost on a daily basis. And not only in India, there are places in all over the world which are notorious for very bad traffic. In Mumbai, for example, an average value of the congestion rate is 53%. In other words, if you take normally 1 hour to travel, you have to budget for 53% more. So, therefore, the idea of air taxis is gaining prominence, and in many cities there are testing going on. Okay. So, you will be surprised to know that some of the cities are claiming, like Dubai for example, that there will be commercial operations as early as 2 years from now, 2025. Okay. So, UAM stands for drone delivery and air taxis for cities and suburbs working together. So, what is the current and the future of urban air mobility? So, current is that there will be a driver or a pilot in the vehicle, and there will be 2 passenger seats available. Okay. In the future, you will have driverless taxis which will have 4 passenger seats, they will expand further. So, free flight will ultimately lead to the UAS. So, entire traffic management is going to come under UTM ultimately, and the drones and the air taxi operators are going to be similar in a controlled airspace. In the green areas of the Indian airspace, they are going to be very similar and they will have similar challenges. The only difference is that air taxis will operate at a higher altitude than drones to avoid clash between them. And if you now look at advanced air mobility concept, it is an umbrella concept. It is a concept that encompasses both. There will be a regional air mobility, which is a mobility not only between the points in the urban city, but between 2 cities, 2 neighboring cities, Mumbai, Nasik, Mumbai, Pune, Mumbai, Shirdi. That kind of mobility will be called as the regional air mobility. So, the advanced air mobility will be the urban air mobility plus the regional air mobility. And the next gen and SESAR, they are going to implement all this in the next 15 years or so. Okay. So, here is a summary of what we have seen today. We have seen that the free flight concept essentially aims for removal of air traffic control and making planes completely self-sufficient. Basically, we are shifting the role of conflict detection and resolution and separation to the cockpit of the aircraft from the ground based ATC. The CNS advances and research avenues in modern aviation, we saw many of them, and we saw that next gen and SESAR are going to come in a very big way in the future. Drone delivery requires a new urban traffic management system, not under the current ATM jurisdiction, because already the ATC officers in the current ATM system are overloaded, and we cannot expect to load them further by making them to look at the management of the drones also. So, it requires a new system. Okay. The air taxis will follow the UAM system, possibly they will be integrated with UTM, right. So, the main challenges are the same. How do you detect and avoid conflicts? How do you ensure minimum separation? How do you handle the gusts? And battery or the fuel life is also going to be small, and therefore, there will be cases of emergencies, and then how do we give them a safe passage. Thank you for your attention.